So this video is going to continue chapter 2 of geometry, and it's going to cover 2.8 space geometry and 2.9, which talks about graphs and visuals. So 2.8 concentrates on how to draw 3D objects. So we're going to start with a rectangular solid. So the first step to drawing a rectangular solid is to draw just a normal rectangle like this. And then what you want to do is draw another rectangle slightly shifted over like this. And then you want to connect all of the corners sort of like that. And then here you can see you have sort of a prism or a cube or a rectangular solid. And in your mind it's sort of fun to look at it differently and flip it so you can see this side in the front, or you can try to flip it in your mind and see this side in the front. And if you want to give it more perspective, then you can draw it so that all of the sides that technically should be invisible you can draw with dotted lines like that. So now we're going to draw a cylinder. So you want to start with an oval or a flattened circle, and then you want to draw 2 lines down, a curved line across mimicking the one on the top, and then a dotted line behind, because that you technically can't see that line, but it helps to give the illusion of space. For a cone, you want to start out again with a flattened oval. You want to put a point up here where you're going to be drawing your lines to, and then you want to connect the side to the point on both sides. If you want to give it that illusion of space, you can do the same thing but draw a dotted line behind. For a pyramid, it gets a little more complicated, so you want to start with just 2 lines down as if you were drawing a triangle, and then you want to draw 2 more in the middle that extend a little bit further, and then you want to connect those lines like that, and then you want to draw some dotted lines behind like that, and then some dotted lines down for the sides that would connect there. Prisms are going to be kind of similar to pyramids, so you want to start with a flattened figure. I'm going to go with a pentagon, and then you want to draw some lines down where the front would be, and the middle ones are going to extend further than the back ones. Then you want to connect those lines, and then you want to do the rest in dotted lines because it's going to be behind. And there you have it. Drawing spheres and hemispheres may seem daunting, but it's really not once you get a hang of it. You want to draw 1 dot and then a circle around it, and then a curved line across, and continue that curved line dotted behind. And really it gets easier and easier with practice. You'll get better at drawing circles, and it'll just begin to come naturally to you. Hemispheres are pretty similar. You have a half circle, and then you have the curved line in front and the dotted line behind. So 2.9 talks about graphs and diagrams, which can be really helpful in solving problems. So it's really important that you know how to read graphs. So one type of graph that's really common is the bar graph. So what a bar graph does is it compares multiple objects or quantities. For example, here we can compare Jeff, Peter, John, and Mary's scores on both a pre-test and a test. So that's another useful thing. You can compare multiple things. So it can be useful in showing that, for example, John did not improve at all, whereas Mary and Peter both ended up with the same score. A circle graph, or pie graph as it's commonly called, is really useful when you want to know how a quantity is divided into its parts. So for example, here, the world's water, we can see that 97% of it is in the oceans, only 3% of it is fresh water, and out of that fresh water, 79% is in glaciers, and we can go on and on. And it can be a really important visual to really see things such as how little fresh water is actually available to us in the world. Line graphs are really useful because they can compare multiple things and they can compare them as they change over time. The most common variable you'll see on the bottom of a line graph is time, even though it could also be a change in number over a change in temperature or something of the like. But for example, here it talks about population by region and how that's increased over time from 1750 to 2000. And it's a really cool visual to see, like, for example, Asia has increased far more dramatically recently than any other region. Okay, so now we're going to do a practice problem where a diagram is going to be absolutely essential in finding the right answer. So John, Peter, and Ted are standing on a flat field reading their treasure map. John is standing at one of the features marked on the map, a tree stump. Here's John. And Peter standing atop the other item marked on the map, a large boulder. Here's Peter. The map indicates that the treasure is buried 60 meters from the tree stump and 40 meters from the large boulder. If John and Peter are standing 80 meters apart, what is the locus of all the points where the treasure might be buried? So to solve this, so we know that John and Peter are going to be 80 meters apart. We know that the treasure is buried 60 meters from the tree stump, so 60 meters from John. So what we can do is we know that we can draw a circle that represents all of the places that are 60 meters from John. And then we know that it's 40 meters from the large boulder, so we can do the same thing and then draw a circle around Peter that's 40 meters. So now we can see that the only two places that the treasure could be buried are here and here, because they're the only places that are both 60 meters from John and 40 meters from Peter.